Okay, it's Mr. Rops here, and I'm going to talk some theory behind solving for eigenvalues and eigenvectors. And if you're doing the math applications HL course, the theory is not important for the course, but if you're interested, it might give some more understanding. But this is purely optional for you. When I'm going to solve for eigenvalues and eigenvectors, I know I end up taking this equation, subtracting it over, equal to 0, and factoring out the x, make it equal to 0. And so this, in essence, ends up being, this is a 2 by 2 matrix, and this is a column matrix. And so it is really like a 2 by 2 scenario times some xy is equal to 0, 0. Well, if I pretend just for a moment this is not 0, 0, but this is really saying that this is some like matrix M times x is equal to some other matrix. This is a linear equation. And I'm just going to talk about 2 by 2s and x is just simple equations just to get the concept behind us. And so if I'm solving this equation, this is really something like a 2x plus y equal to 0, or a 3x minus 4y is also equal to 0. Right? That's if this is 0, 0 is asked. Now, there's actually 4 scenarios. I know that b could be 0, but sometimes when I'm solving linear equations, maybe this is not 0. Maybe it's 8 and this is like 10. We don't really know. But so this b value could be 0 or not. And this matrix M, it could be singular or non-singular. Singular or non-singular. That's some heavy vocab. Non-singular is this scenario here where all these values here are all, they're not multiples of each other. Okay? So these are non-singular. And if this is the case, if I have this non-singular matrix and I know it's equal to 0, 0, the only thing that x and y can be, if you think about that for a moment, think what's the only possible value for x and y? If you think about it, you recognize the only possible value for x and y is 0, 0. Okay? And so there is a unique solution, but it's 0, 0. If this is, let's say, 8 and this is 10, well, these are two lines that are intersecting, and they're going to have a unique point of intersection, but there will be a point of intersection, and so here there is a unique solution, meaning there's a point somewhere. Okay, so that's non-singular. When I have what we call a singular matrix, okay, I have a scenario where I have numbers like, let's say, 2x plus 3y and like a 4x plus 6y, or maybe a negative 4x and a negative 6, but they're multiples of each other. That's when they're singular. When they are singular, okay, when they are singular, if I think about the determinant is going to be 2 times 6 minus 4 times 3. That's 12 minus 12 is 0. If they're singular, I know the determinant of this matrix M is 0. Now, if these two do not equal 0, so let's say it's 7 and 10. From your earlier school, you know these are two parallel lines that do not intersect, and so b is not 0, and so there is no solution. However, if I have this scenario over here where they are both 0, well, in essence, I have a line and I have a line on top of it. And so there is an infinite amount of solutions. And when I am solving this here, if I want to have an infinite amount of solutions, then I need this determinant to be 0. It needs to be a singular matrix. If it's non-singular, I mean it doesn't equal 0, well there's only one solution to this equation, and that's going to be 0, 0, and that's not very interesting. But having an infinite amount of solutions and analyzing those is interesting, and that's why we let the determinant equal to 0, because we want a singular matrix, so parallel lines that are right on top of each other. And there's a little bit of theory behind why we make the determinant equal to 0.